Assalamualaikum and good morning. We are from Group T12 and we will do about the chapter differential protection and the part of the review question. My name is Nur Afrina binti Hasramani, metric number DE100179. I will do for the first question, what is the function of NC, which means normally closed, shown in figure 11.1. The NC are mechanical switches which are normally closed during bus maintenance. This will have to be open to guarantee safety to maintenance personnel. It is for reducing the number of the circuit loss in case of a bus fault is to synergize the bus. The probability of a fault during circuit breaker maintenance is small, but still there as a result, the transformer is protected by a primary fuse to back up the breaker and provide some protection for internal transformer faults. For the second question, what are the advantages of single breaker double bus arrangement over single bus single breaker arrangement? First, permit some flexibility with two operating bus. For the second, the circuit can be transferred readily from one bus to the other by use of the bus tie breaker and bus selector disconnect switches. For the third, main bus or bus sectionalized may be isolated for maintenance operation. For the third question, how does double bus double breaker bus arrangement provide the maximum flexibility? First, this type of arrangement provide the maximum reliability and flexibility in the supply because of the fault and maintenance would not disturb the quality. And for the second, this configuration utilize two buses and two breaker per circuit. Both buses are normally energized and any circuit can be removed from the maintenance without an outage of on the corresponding circuit. For the third, the failure of one of the two buses will not interrupt the circuit because all of the circuit can be fed from the remaining bus and isolating the failed bus. And the last, the substation with double bus double breaker arrangement require twice equipment as the single bus scheme but are highly reliable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nama Besenu, DE190173, and today I will solve the equation. I will solve the question 4, 5 and 6. Question 4, what is the advantages of ring bus arrangement? Ring bus arrangement have two parts of the supply, which will not affect the working system if there is any fault. If there is any fault that we want to solve, we can solve the fault without interrupting the whole system. On the other hand, we can say that ring bus arrangement is very flexible and easy to maintain because if we want to solve the fault, we don't have to close or shut down all the system, but we can just repair the system without interrupting the supply. Now, for question 5, how is city saturation problem handled in the bus protection system? When city core saturates, it will act as the air core devices. So the primary and secondary winding can be neglect. From city secondary terminals, it will become a very low impedance and it will equal to city secondary windings. So the city terminal is no more a a current source with high impedance. So if the impedance of the city increase, so the sum of all city will divided into impedance part, and in conclusion, we can say that city saturates will act or responsible as a saving for a fault operation. Now, for question 6, draw the configuration of 6 figure. That is draw the configuration of 6 circuits. So for 6 circuit, we have 2 circuit which is single breaker, single bus arrangement, and the other hand is single breaker double bus with bus tie. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati binti Omar, CE190111. Today I will be present for the questions number 7 and 8. Okay, for question number 7, What are auxiliary current transformer and why are they used? Okay, current transformer. Auxiliary current transformer is utilized in a variety of applications in self-relaying circuit. They also frequently utilized to adjust the secondary current to the right level for the relay. Okay, why are they used? Because the vector sum of three-phase to natural current from the primary current transformer is used to feed a single-phase relay. It also provides isolation between primary and secondary current circuit. This function can be used to improve the level of insulation between the current circuit. For many various relaying and measuring purposes, any two or more AC current can be summed and turned to one secondary current via auxiliary current transformer. Okay, next. Uh, for question number 8, what are the advantages of numerical relaying over other relaying scheme in differential protection? Okay, first is compact size. Mechanical comparison devices are used in electromechanical relay, which is the main reason for their large size. It employs a flag system to indicate whether or not the relay has been enabled. Second, flexibility. With sufficient software adjustment, a range of protection tasks can be achieved either with the same hardware or with minor hardware modification. Third, reliability. Because fewer components are used, there are fewer interconnection and component failure, resulting in a significant increase in relay dependability. Lastly, multifunction capability. Range of operation of electromechanical relay is narrow compared to the numerical relay. That's all from me. Thank you.
Hello, my name is Muhammad Shafiq bin Haizal. Okay, for my part, I will do a presentation about question 9 and question 10. First, we will go to the question 9, which is we need to show the maximum flux during energization. During one half cycle of a transformer powered by steady state alternating voltage, the flux from a peak negative value to an equivalent positive value. A voltage wave when a transformer is de-energized, remaining flux can be accumulated in the magnetic core of a transformer. If the remaining flux has the same polarity as the prospective flux, when the transformer is energized, the total flux may be calculated be greater than twice the average maximum. The best moment for transformer energization is when the remaining and prospective flux are equal, as shown in figure 4. In range current transfer are eliminated if the transformer is activated at the appropriate instant. For a single phase transformer, there are two ideal energization instant each power frequency cycle. A prospective flux is the same as a remaining flux at that instance, and both have the same priority. The problem is more complicated for transformer with delta winding on 3-ledge core. The core flux are not independent in this case. There are two ideal instances for the 3-phase converter when looking at only one phase. However, due to the remaining flux in the other two phases, it is demonstrated that just one moment is ideal. Okay, next we go for question 10, which is what are the various restraint schemes used? Okay, there I have three, as you can see here. First is harmonic restraint, second is voltage based restraint, and last is a flux restraint scheme. Okay, that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatma binti Muhammad Kamal and my metric number is DE10154. For today, I will explain for the question 11 and 12. So for the question 11, this is the question. The primary winding of the transformer has 2000 turns and the CT ratio is 600 to pi. The secondary has 10,000 turns and it's run on tap of 60%. So find out the safety ratio required for the secondary side to establish circulating current scheme. So this is the figure. Okay, as you can see, this is and at here is the primary side and here is the secondary side. So we know that I1 is equal to I2. So the number of turn, and the city ratio is n is the number of turn. The small n is the city ratio. The city ratio. So the number of turn of n1 at the primary side is 2000. After that, n2 at here we have 10,000. So we want to find the n1, the the ratio is 1 ampere. So if 1 ampere, we have 600 divided by 5, so we get 120. Okay, after that, we know the tap have been given is on 60%, so we change it to 0.6. After that, we know the current at 1 is equal to current at 2, which is primary and secondary. So um, to find the current, so number of turn will multiply by the number of CT ratio at here. So at the secondary part, we add the current multiplied by the T, which is the tap, working tap, which is 60%. So after that, we get N is equal to number of turn multiplied by the CT ratio of N1. Okay, after that, divided by the number of turn at the secondary and the tap at secondary. After that, we get is N2 is equal to 40. But 40 is if we ratio it at 1 ampere, but now as at the circulating current scheme is 5, so we will multiply it by 5, so we get 200. So the CT ratio requirement for the secondary side is 200 to 5. So that's the answer. Now is question 12, which is explain how reliability is obtained by Boolean scheme in sample by sample comparison approach for differential protection. In sample by sample comparison approach with help of multiple success of sample trip decision is ensured. Okay, there are comparison between the counter and also the threshold value. When the differential value are so large, there are increasement of counter. Okay, if the different value is below the threshold value, then they are having a decreasement of the counter value. Okay, when the counter value is equivalent to the threshold value, then the trip decision is issued. By this mean, reliability is obtained by Boolean scheme in sample by sample comparison approach for differential protection. Basically, the differential protection has two types, which is sample by sample method, and the other one are by comparing the phasor. But the sample by sample method is a fast and it easily detect the noise and more reliable. So that's all from me. Thank you.